This next unit gets us started with a new test. We've got the vertical line test, we've got the horizontal line test. Now we're going to learn something called the lead coefficient test. And this is going to help us draw some other shapes of graphs. We already know parabolas really well. We know hyperbolas really well. But now we need to know about other shapes. Okay, so just want to review with you a couple things. Quadratic, we've covered that for several days, also known as parabola. Okay, we know that quadratics look like U's, and either they're right side up or they are upside down. How do you tell if it's right side up or upside down? The negative. Where's the negative found? In the front. Okay, in other words, it's the lead. It's the leading thing of the equation. That lead will tell you whether you've got a reflection or not. The stretch is that first number as well. That is the lead coefficient. All right, the next shapes we're going to be focusing on over the next couple days, cubic. There are a couple kinds of cubics. Your plain boring cubic just looks like this. But that sort of bend in the middle of a cubic can be more pronounced. And it can look like this, where you have a little bit more of a peak and a little bit more of a valley. Or it could be reflected, and it could go the other way. That reflection is also going to be from your lead coefficient. The lead is going to tell you whether it's a cubic that is going up or a cubic that is coming down. Then we have quartic. And by the way, maybe over here on the side, quadratics are x squared problems. The lead is x squared. Cubics are x cubed, where the lead is x cubed. Quartics are x to the 4, where the lead number, the variable is x to the 4th. If quadratics look like a U, then quartics look like a W. Now some quartics are perfect W's, where everything sort of symmetric and it all lines up nicely, but other quartics have one dip that's lower than the other, so it might look like that. Or it could look like this. Or it could be upside down. Or have the high peak and then the low peak. Okay, so those are quartics. What do you notice about the arrows in a quartic? Like all of these arrows right here, they're all pointing in what direction? Up. Okay, and all of the arrows down here are all pointing down. So either way, either both sides are facing up if it's a positive, or both sides are facing down in a quartic. The last one you have to know the name of is a quintic. Q-U-I-N-T-I-C. Like quince if you know Spanish. Okay. Q-U-I-N is x to the 5th. That's going to look more like a cubic. But the fact that it has the x to the 5th means it's going to have an extra set of extra wrinkle in it. So it's going to look like this, 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 and then that. Like it's got, every time you add a degree, you add an extra bounce, an extra max or min. So it could look like that. Maybe you have a high one first and then a low one and then like that. But what do you notice about the arrows here? Are they both facing the same direction? They're opposite. Okay, the arrows are facing opposite. Or it could be reflected upside down, and it could look like this. Okay, that's an example of a quintic. So all of this has to do with a lead coefficient. You are not going to be asked to draw these exactly accurately, but you're going to be asked to sketch them based on a couple things. Okay, so let me actually write down for you what the lead coefficient test is. LCT. This is the lead coefficient test. And so what that says is almost everything you need to know comes from the lead term as long as your equation is in order. Okay. Comes from ax to the n. All right, here we go. Ax to the n is the front number in a parabola, or in a polynomial. And then bx, and the next number is one smaller than that, so we call that n minus 1. And then cx, and then that would be smaller yet, it goes down, the order would go down. And then dx, and the order would go down again. And then it just goes on and on and on and on. Everything you need to know is going to come from the lead coefficient, the lead term. All right, so what can you learn by just looking at the lead term? Well, first you want to look at the n. N is the power. If n is even or n is odd, that's going to tell you about what the direction of the arrows are doing, the direction of the end. Even means the ends are equal, okay, or the arrows are equal. No matter if it's even. So even would be parabola, quadratic, quartic, something to the 6, something to the 8, something to the 10. Anytime a power is even, the ends are going to be going in the equal direction. They're both going to be up or they're both going to be down. We can look at all of our even ones. Okay, look at quadratic is even, both ends are up or both ends are down. They're doing the same as each side is the same. Quartic, either both ends are up or both ends are down. So then if it's odd, then you have opposite arrows. And in that case, for all of our odd ones, so cubics were all odd, the ends are, one's up, one's down. One's down, one's up. One's up, one's down. They're opposite. And then the quintic too. One's down, one's up. One's down, one's up. One's up, one's down. That's the first thing that you can tell. And so it's easy for me to grade homework or grade quizzes because I can tell where all their arrows going the right direction that they need to do. So that's the first thing. All right, and then A is the coefficient. And what we can learn from A is whether or not there's a reflection or not. If it's positive, there's no reflection. If it's negative, there is a reflection. Okay, and so A can tell us if there's going to be a reflection or not. So the two things that you could learn from the lead coefficient test. I'm going to put a box around that. All of this lesson, this whole unit, this 2-3, it's going to take us a couple days. It's going to take us all week. We'll do 2-3A, 2-3B, 2-3C. What I need you to learn in 2-3A is what you can tell from the lead coefficient. All right, so a couple examples. All right, what can the LCT, the lead coefficient test, tell you about the following functions? so we're going to look at 2. I'm not going to ask you to graph them, I just want to know what you can learn. So what can the LCT tell you about the following? All right, so here's your first one I want us to look at together. F of x equals negative 2x to the 7 plus 4x to the 3rd minus 1. So we look at the lead term, the lead coefficient. We're going to focus on this. We're not going to focus on the other stuff. They all will tell us things too, but right now we're just focusing on the first one. All right, we can learn that this is a power 7, which is an odd power. All right, we also can learn that the coefficient is negative 2, which means I have a reflection. And I have a stretch. The negative is the reflection, and the 2 is the stretch. So I can learn that, a couple of those things. So what you can do is you can tell me what the left arrow is supposed to do and what the right arrow is supposed to do. And so the left end arrow, what is it doing? And what will the right end arrow do according to the lead coefficient test? All right, so it's an odd power. And so the arrows should be doing opposite things. And it's been reflected. So anybody tell me with pretty good confidence what they think the left end arrow is doing, what direction it would be pointing? Go ahead, Dakota. Up. Okay, the left end arrow is pointing up. It's increasing on the left. Okay, so this is up or positive, or you could say increasing. All of those words are fine and I will know what you mean. Okay, oop, oop, where'd it go? Where'd it go? Because it's, she's picturing in her head something that's going like this on the left side, and then it's going to come, because it's kintic, it's going to end up having a bunch of wrinkles in the middle. So then the right end arrow is going down, or we could say negative, or we could say decreasing. On another day later this week, we're going to learn about what to do in the middle and how to get the middle all perfect in a minute, but right now we're just really talking about the ends. Okay, we'll learn about the middle later, but for now we just want to know what can we learn about the function from the ends. Okay, here's your second function to think about. So this is function b. Okay, g of x, and that would be 3x to the 8 minus 5x to the 5th. So what do we learn about the lead coefficient from the lead coefficient of this one? And so it's even, so the power is 8, which is even. Even means the two ends of the arrows either have to be both facing up or both facing down. And then the coefficient is 3. That means there's no reflection because it's positive. And then it has a stretch of 3. All right, and then you want to just summarize what is the left side then doing and what is the right side doing. And you should be able to then picture it. If it's an even power and there's no reflection, what direction is the left end going? What do you think, Lauren? Okay, if it's positive but no reflection. Let's look back up at some of the other positive ones we did. Okay, it's positive and it's even. So that would be meaning I'm looking at things that are like this one, or looking at things that are like this one. Actually, let me draw that a little bit more clearly for you. Erase that. I'm looking at positive, even. So that one or that one. Okay, so what do you think? It's positive and even. Okay, the left side and right side are both going up. And so we would summarize this. The left end direction is increasing, and the right end direction is also increasing. Okay, we don't know about the middle quite yet. So we know that the end is going to be up here and the other end is going to be up here. Because it's an 8, we know that we're going to have a bunch of wiggles in the middle. We don't quite know how the wiggles are going to go yet. We'll learn that. But we're focusing on what the ends do right now. Okay, so don't so much focus on the center, focus on the ends.